TIG welding, short for tungsten inert gas welding, is one of the most precise, clean, and beautiful welding processes in the world. It's officially called GTAW, gas tungsten arc welding. TIG welding uses a non-consumable tungsten electrode to create an arc that melts the base metal. A separate filler rod can be added by hand if needed. Meanwhile, a shielding gas, usually argon, protects the weld from contamination. It's like painting with molten metal. Here's how it works. The tungsten electrode creates an electric arc that heats and melts the base metal. The welder can add filler metal manually or not at all. An inert gas flows out of the torch to keep oxygen away from the weld puddle. The result is an incredibly clean, strong, corrosion-resistant weld. Some of the materials you can weld with TIG are stainless steel, aluminum, titanium, chromoly, copper, brass, and most thin metals. Why TIG is loved by artists and precision fabricators? Because TIG welds look clean and beautiful. You can stack perfect dimes with skill. It gives the welder full control. Amperage, filler amount, puddle size. This is used in aerospace, race car chassis, custom motorcycles, bicycles, and art sculpture. What you need to TIG weld: TIG welding machine with foot pedal or thumb control for amperage, argon gas tank and regulator, TIG torch and tungsten electrode, filler rods, if required, clean metal. TIG hates rust or oil. Steady hands and patience. Common TIG welding defects include porosity, lack of fusion, cracking, undercut, tungsten inclusions, and crater formation. These defects can arise from various issues such as improper shielding gas coverage, incorrect welding parameters, contamination, or poor welding techniques. But when done properly, TIG welding might be the most elegant form of welding. It takes longer and it's harder to master. But when done right, the result is stronger, cleaner, and often visually perfect.
Metal inert gas welding, or the technical name gas metal arc welding, is an arc welding process that joins metals by heating them with an electric arc and using a continuously fed wire electrode as a filler material. A shielding gas is also used to protect the weld area from atmospheric contamination. The key components include a consumable wire electrode, which is a solid wire that acts as both the electrode and the filler metal continuously fed into the weld pool. The shielding gas, inert gases like argon or helium, or a mix of inert and active gases like carbon dioxide, are used to shield the weld area from the atmosphere, preventing oxidation and other contamination. The welding gun, or torch. This device feeds the wire electrode and shielding gas to the weld area. And finally, the power source provides the electrical current needed to create the arc. An electric arc is created between the wire electrode and the base metal. The heat from the arc melts the wire electrode and the base metal, causing them to fuse together. The shielding gas protects the molten weld pool from atmospheric gases like oxygen, nitrogen, and hydrogen, which can cause porosity and other weld defects. The wire is continuously fed into the weld pool as the welding progresses, making MIG welding a semi-automatic or automatic process. It can be used on a wide variety of metals, including steel, stainless steel, aluminum, and more. MIG welding is generally a faster welding process compared to some other methods and is considered relatively easy to learn and use, making it a popular choice for both hobbyists and professionals. This type of welding produces relatively clean welds with less spatter compared to some other welding.
Shielded metal arc welding, often called stick welding, is one of the most common and traditional welding methods used in construction, fabrication, and maintenance. It's known for its simplicity, ruggedness, and versatility in outdoor and industrial settings. In stick welding, a flux-coated consumable electrode, the stick, carries electric current to create an arc between the electrode tip and the base metal. This arc melts both the base metal and the electrode, forming a molten weld pool that fuses the materials together. The electrode is a metal rod with a flux coating, As it melts, the flux creates a gas shield and slag that protects the weld from contamination. The ground clamp attaches to the workpiece and completes the electrical circuit. Stick welding can be pretty fun, but just make sure to always wear the proper protective equipment.
Submerged arc welding is a high-productivity welding process commonly used in heavy industrial applications. It's known for producing strong, clean welds with minimal spatter and smoke. Here's a breakdown of how it works and what makes it unique. A spool-fed wire electrode is continuously fed into the weld zone. The weld area is completely covered, or submerged, in a layer of granular flux, which protects the molten weld pool from atmospheric contamination, prevents spatter, helps shape and clean the weld. The arc forms between the electrode and the base material, but it is completely hidden beneath the flux. Hence the name submerged arc welding. As welding progresses, the flux melts into slag, which covers the weld and protects it as it cools. The slag is later chipped or brushed away. Key features entail a high deposition rate, deep penetration producing strong welds, ideal for thick materials. It has a low visibility of arc. There's no bright light or spatter, making it safer and cleaner, and it's automation friendly, often used with mechanized or automated welding systems. The common applications are shipbuilding, pressure vessels, structural steel fabrication, pipe manufacturing, heavy machinery. Some of the limitations is only suitable for flat or horizontal welding positions. It's also not usable on thin materials or non-ferrous metals. Additionally, it requires bulkier equipment and more setup than processes like MIG. All in all, submerged arc welding, like other types of welding, has its place in the fabrication and construction world. Try it out today, but always remember to wear your proper protective gear. Flux-Cored arc welding, FCAW, is a semi-automatic or automatic arc welding process similar to MIG welding, but it uses a special type of wire filled with flux. It's known for high deposition rates and being very effective outdoors or in dirty, rusty conditions. The welding wire is tubular and filled with flux in the core. As it melts, the flux produces shielding gases and slag to protect the weld from contamination. An arc forms between the continuously fed wire and the base metal, melting both the wire and the workpiece to form the weld. Self-shielded, FCAW-S. The flux alone creates the shielding gas. No external gas tank needed. Great for outdoor use or in windy conditions. Uses both flux and an external shielding gas, usually CO2 or a CO2/argon mix. Produces cleaner, stronger welds, mostly used indoors. Key features are it's faster than stick or TIG welding. Works on dirty, rusty, or galvanized metal. There's no need for external gas, great for field work, and it's suitable for thicker materials. Some common uses are construction and heavy equipment repair, shipbuilding, pipeline, structural steel fabrication, and outdoor maintenance welding. Some limitations are it's messy, it can produce more smoke and spatter than other processes, but every welding process has its place. And flux-core welding remains a staple in the day-to-day world. But just remember, always wear your proper protective equipment.